Okay. So this is the not the day 11 basically. इसको हटा देते हैं. ठीक है. तो रोटेशनल मोशन में एक अच्छा खासा डिस्कशन हम लोग कर चुके हैं अभी तक, राइट? We have discussed about the basic terminologies, how circular motion is going to help in this chapter, how you can connect linear variables with angular variables, what is torque, what is moment of inertia, right? What is static equilibrium? I guess this is something that we have discussed. Can you tell me about the static equilibrium? What is the static equilibrium? What are the conditions which we can have under this topic? Anyone can give me a follow-up on this? What is static equilibrium? I think we have discussed that, right?
It is a state of balance at rest.
Yep. But I think I have categorized static equilibrium into further two equilibriums, and then I gave you few conditions regarding that. So I need that much description, which I gave you. I want the exact description. Can anyone give me? I mean, little bit deviation is okay, but at least you can do the basic classification, because otherwise there is no point to discuss anything further if you're not, revising the previous ones. So are you doing that?
Translational equation and rotational equation.
Translational equilibrium and rotational equilibrium. I guess I wrote EQ dot. So EQ dot stands for equilibrium when it comes to physics, right? That's a slang which I use. So I hope you remember it as translational equilibrium and rotational equilibrium. Is that okay, Shikha?
Yes, ma'am.
Okay. What are the conditions under translational equilibrium which we can follow?
F net is 0.
Exactly, and it is zero in all the directions, whether it's x-axis, y-axis, or z-axis, which means sigma of all the forces in x-axis is going to be zero. Sigma, or the sum of all the forces in y direction, is going to be zero. And similarly, the sum of the forces in z direction is also going to be zero. Yes.
Yes, ma'am.
Okay. बाकी बच्चों को समझ नहीं आ रहा, बाकी बच्चों को याद नहीं आ रहा. आई थिंक उस क्लास में शिखा के अलावा भी बच्चे थे. So why I'm not getting the responses from remaining ones? Harshita, Gayatri, Jennifer, Irfan, Kiran, Mantasha, Faika, Om, Namrata. Hmm? Yeah, I always said ki please respond in this class. Otherwise, I'll make it as dull as possible. Okay? I like interactions. I always try to do that. Please channeling your thoughts. That is important. Okay. Now I'll call by you. I'll call your names. So, Namrata, can you tell me about the rotational equilibrium? What are the conditions under that? Okay, Harshita. That's actually show dedication that you are much dedicated in this class. It really means a lot for me. That even that is not the appropriate place, but still you are doing it. So thank you for that. Gayatri, Namrata, any
Good
one of you
evening,
can.
ma'am.
Good evening, bacha. Gayatri, can you explain me about the rotational equilibrium? What are the conditions that I have discussed in the under this topic? Okay, Jennifer. Misbah?
Ma'am, what?
Beta, can you tell me about the rotational equilibrium? What is rotational equilibrium? What are the conditions under that?
Ma'am,
Okay, Gayatri is giving the answer. Yes, please, Gayatri, continue.
Ma'am, you see that in rotational equilibrium, the angular momentum is constant and the net torque is zero.
Very nice. And is it about a point, about some specific point, or any point that you can have?
No, ma'am.
specific point.
Yes, about any point. We will choose it. What that point would be on the basis of REs, right? Good, Harshita. Very nice. Now I felt कि ठीक है अभी आप सब लोग कर रहे हो. Otherwise, it doesn't look good as a teacher too. Take care. So today our topic is very, very important. When I go through the syllabus of this chapter, I will always focus on theorems because they are very important. They have variety of questions, a spectrum of questions in them. So we will discuss theorems and few numericals to get the idea. And today is 23rd of Jan. Okay. Moreover, I want to discuss one more thing, that the syllabus of your upcoming test, right? I will write it here. And it is the upcoming test. The syllabus is still the Newton's laws of motion. As I feel ki we have still a lot of room to work on, right? We can still work on our numericals, their grip, because this chapter is very important. If I ask you to take one unit from 11th to your 12th, that is kinematics, a branch of mechanics, as I told you. So that kinematics and dynamics are very important. When it comes to mechanics, your entire 11th is all about the mechanics, but at least take the first half of your book in the NEET preparation, at least. If you are if you're taking the entire book, then that's a very commendable thing. But still, the first part of that book, which is from chapter 2 to chapter 7, right? Please take that much portion. And Newton's laws of motion and system of particles are very important topics. So I really want you to cover all the weak points that you have, which you analyze in this test. Kindly work on all of those points, whether it's theoretical or numericals, right? So even in this syllabus, even in this upcoming test, you will have to work on Newton's laws of motion. Okay? So please make this chapter as strong as you can do, right? So please do that. It is important. When it comes to moment of inertia, so I have discussed that moment of inertia is basically related to two things: that what is the amount of mass, I mean how much mass is there, and at what position from the axis of rotation, right? It asks only two questions: key, how much mass, and where it is located from the axis of rotation. So that is inertia for you. But inertia is not that simple. We need to calculate inertia for a lot of bodies in a lot of senses. If we change the axis of rotation, inertia may be different. Inertia can vary for a same body if you change the axis of rotation. Do we get this much? Is it fine?
Yes, ma'am.
Yes. So what I said, that moment of inertia can vary for the same body or for the same arrangement, okay, if we change the axis of rotation. So on the basis of this thought, you must have the knowledge of few uniform bodies and few moment of inertia with respect to some specific axis of rotation, right? So in further 3 or 4 slides, I'm going to show you a table which is very, very important. You need to remember the entire table. Okay? You need to remember it. No matter how many times you're going to practice it, I really don't care. I just want you to remember it. Okay? So where are those? Here. Okay, we will go through them. What is the unit of moment of inertia? Then I'll come to that topic. What is the unit of inertia?
kg meters.
I think meter is square, right?
Yes, ma'am. Kg meters.
Okay. Before going towards that particular table, I want to ask one question from you, and that is this one. For example, I have this mass, let's say M. I have this mass, let's say M. This mass M, and let's say this mass M. Okay? Question says, the distance in between these two masses is B. Similarly, the distance in between these two masses is B. And distance in between these two masses is A. Distance in between these two masses is A. Is that okay?
Yes,
Yes,
ma'am.
ma'am.
Okay. Am I visible?
Yes, ma'am.
Hello.
Yes,
Okay.
ma'am.
Take it. So they gave you an axis of rotation like this, right? This pink one is your axis of rotation. Let's say it is x prime. So the question is, find moment of inertia. एक second. Find moment of inertia about x prime. Okay. Find moment of inertia about x prime. Okay. And x prime is एक मिनट बेटा is a bisector for A. ठीक है? That is the question which is given to you. Basically, they are saying this distance is A by 2. You need to find out the inertia. Okay? Haji, share your answers. What are your answers? Have you solved it? Do you want me to solve it?
Yes, ma'am.
Okay. See, I'm doing it right now, but believe me, this is not a very typical question. If you understand the basic meaning of moment of inertia, you can do it. What I said about moment of inertia. Moment of inertia is what amount of, what is the mass and where it is located from axis of rotation. That's it. I will do this question on the basis of this basic definition, that what is the amount of mass? It is m, where it is located from the axis of rotation. This mass is at a by 2 distance, a by 2 square, plus this mass is again at a by 2 distance, right? All the masses are at a by 2 distance from the axis of rotation. Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Yes. So I guess this is a very simplest question actually about inertia. Now you just have to go by the definition. What is the mass? Oh, sorry. What is the amount of mass and where it is located from the axis of rotation? Chaliye. Let's come to that beautiful table and the most important one. We cannot miss this table. We cannot ignore this table. It is very, very, very important. Like, maybe I am unable to tell you how much important this table is for you. Maybe when you do the PYQs, you will get the idea that questions are directly asked on this table. Like, they would ask you what is the moment of inertia of ring about a tangent perpendicular to its plane, 2 mr square. If you know this table, you are not going to solve it. You are not going to waste your 1 or 2 minutes even into this question, right? If you know this table, you will answer it directly. And I'm not kidding. That kind of question is actually, have been asked in the papers in the previous years. So let's start with the first thing, and that is ring. So here, the body is mentioned. Here, the axis is mentioned, that you are going to answer the moment of inertia about which axis. So when the axis is passing through the center, for example, this is ring, right? And axis is passing through this center, then we would say that inertia is mr square. Okay, I'm making the top view. Now the second question, about any diameter. About any diameter, it could be this or it could be this. About any diameter, the moment of inertia is half mr square. About a tangent in its plane, it means a tangent which is lying in the plane of the ring. Since ring is a 2D body now, so it must lie in a plane. Either it could be xy, it could be yz, it could be zx, right? Ring is supposed to lie in a plane. So a tangent which is also lying in that plane, about that inertia would be 3 by 2 mr square. Now about a tangent which is perpendicular to that plane. Okay, wait a second. Okay, so I literally use the bangle of my mom. Is it visible to you?
Yes, ma'am.
Yes, ma'am.
Okay, so this is a ring, right? Just consider that this is your x-axis, this is your y-axis, and this one is your z-axis. So basically, this is lying in xz plane. Is that okay? If I'm putting it like this, it is lying in xz plane. Is it fine?
Yes,
Yes, ma'am.
Okay. So one tangent is like this. Now this tangent, can you see the span, or should I change it? This span, the tangent
Yes,
is
ma'am.
like this. See, it is in the plane, and this one is perpendicular to the plane. This is in the plane of ring. This is perpendicular to the ring. Is that okay?
yes, ma'am.
Yes, ma'am.
So these are the these are the position of axis of rotations in these cases. Do you get this axis, this one, and this one? Is it fine?
Yes, ma'am.
Okay.
Yes, ma'am.
And see, it is very logical also. If I'm saying that moment of inertia about the center is going to be mr square, so यहाँ पर just look at in this case. See, in this case, all the masses are at equal distance and they are away from this axis, right? But when I said keep about diameter, then at least few mass is lying on this tangent now. Sorry, on this diameter now. Few mass at least. So it is
Yes,
supposed to be lesser than the previous one. That's why you said, that's why you are observing here the deduction of half mr square. Okay, everything is related to each other. Now I said about a tangent, which is in the plane. Only few, mass is going to be there. Only just a point, I guess, just a point. And the entire mass is very away from that particular point. From the actual contact point, the entire mass is very, very far in comparison to the center wala case. That's why here you see the addition of moment of inertia. Yes or no? Because R is going to be large in this case.
Yes, ma'am.
Right.
Yes, ma'am.
Let's come to the last case where tangent is perpendicular to the plane of this ring. See, I'm explaining only this slide. I'm not going to explain the other slides as well. It's just that you get the idea, you get the connection. That's why I'm doing it. So please be very attentive towards it. If I said this is the ring and this is a tangent which is perpendicular to the plane of the ring, you would see the entire ring is away from this particular point, right? Entire ring. That's why the inertia is much more than this. Even in the plane, at least little bit amount is in the contact ना, थोड़ा बहुत यहाँ पे distance कम था, but वहाँ तो सभी का distance अलग है when it comes to perpendicular वाला case. Do we get this?
Yes, ma'am.
Yes,
That's very
ma'am.
nice. Quite similar description is going for uniform circular disk. If you make n number of consecutive rings, right, concentric rings, you will get a disk basically. See, if this is a ring, just add a lot of rings in this. right? And you will get a disk. Yes or no? If I said you, ki, can you give me an
Yes, ma'am.
element of a uniform circular disk, you would say, ki, ma'am, it is a ring, right? So basically, again, the center in its plane, half mr square, diameter 1 by 4 mr square. See, again the deduction you can observe. Tangent pe you will feel the addition, right? And then perpendicular to the plane will get 3 by 2 mr square. There's a one question. In ring, when axis is passing through the center, you will observe inertia as mr square. But in the case of disk, when it is passing through the center, you will get half mr square. It is lesser for disk, although mass is going to be higher. Why? I mean, if you feel the ring is like this, now hollow in from in between it is hollow, but the disc is going to be complete one. Now, disc is going to be like this, right?
Yes, ma'am.
Yes,
For
ma'am.
example, I said ki both are of equal masses. Now the question is ki why inertia is lesser in this case and higher in this case? Again, the reason is ki a lot of mass. Dekho, if the axis of rotation is passing through the center, then a lot of mass is very near to this axis. R is very very small, right? And when I said ki these two have the same masses, then actually this much mass is going to distribute in this entire region. So whatever the mass I have at the boundary is still less, right? That's why you get the lesser inertia. Yes or no?
Yes, ma'am.
Okay. Let's come to this thin uniform rod. Thin uniform rod is very easy to imagine. If I said, it's just that I must have a pen. Mhm. Okay, so just don't laugh on this object. That is the nearest thing which I got right now. Is it visible to you?
No, ma'am.
Is it not visible? This object.
Yes, ma'am, it is visible.
Take care. So let's consider that this object is a uniform rod in this way. Okay, it's a uniform rod. Although this is little bit irregular, sir, but okay, we will consider it a uniform rod. Now there are two positions. One, a perpendicular axis through its center. It means axis which is passing through its center, and the other one, the axis passing through the one end. Okay. Tell me one thing. If a axis is passing through the center, then a lot of mass is near to this axis now, right? So inertia is
Yes,
supposed to be lesser, and that's what you are observing here as ml square by 12. When it comes to the end, one end of this rod, the entire mass is actually in the front of this axis. Or you could say, ki, ma'am, this wala mass is very, very far away from this axis of rotation. That's why you are observing an increment in the inertia. Is that okay?
yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Similarly, it could be for cylinder, this kind of a structure. About its own axis. See, this is the axis of cylinder, and if axis of inertia, moment, that axis of rotation is also passing through it, then we would say inertia is mr square, right? But if axis is passing perpendicular to it, in this case, we will get this kind of weird inertia, okay? And this is for solid cylinder. You know that cylinder could be of two types, either the hollow one or the solid one, as ring and disc, right?
Yes, ma'am.
So you will get different inertias. And one important, not important, but very basic as imagination that I want to give you. If you collect a lot of rings and place them over each other, didn't you get hollow solid cylinder? Let's say this is the ring that I have, and I place a lot of rings over it. Okay, just on this ring, I place a lot of rings here. Isn't it looking like a hollow cylinder?
Yes, ma'am.
Yes, ma'am.
And if I do the similar activities with disc, then also I will get a solid cylinder, right?
Yes, ma'am.
Yeah.
Yes, ma'am.
So you would find the similarities in between their inertias also. Like I said, the inertia of a hollow solid cylinder. See, it's mr square. The see here, it is also mr square for ring. For uniform circular disc, it is half mr square, right? For solid cylinder, it is going to be half mr square. So this table is not very difficult to understand if you are going it, if you're dealing it with logics. It's going to be easy. This is something that you need to remember. That's it. Let's come to solid sphere. Solid sphere is of two types. Oh, sorry. The axes are going to be in two positions. एक about its diameter, एक about a tangent. ठीक है? About its diameter, about a tangent. If axis is passing through the diameter, the inertia would be 2 by 5 mr square. If it passing through the tangent, then it would be 7 by 5 mr square. ठीक है? Now, I gave you 5 bodies and their quite different position of axis of rotations and the inertia corresponding to those axes. But there could be any axis in general. And for that, we will do theorems. Okay? With the help of theorem, we can find out the inertia about any axis of rotation. But it is required that you know these standard values, right? Okay? Okay. Chaliye. So let's come to the theorems. In this chapter, we will have 2 theorems. First is perpendicular axis of perpendicular. Okay?
Yes, ma'am.
Yeah. And the other one is parallel axis theorem. We will deal with these theorems one by one and then we will jump directly to the questions. Let's come for perpendicular axis theorem. Okay? I will not going deep into the proofs and everything, although I can prove the theorem, but that's not the point, to be very honest right now. We will just deal with the conditions and the result. So when it comes to perpendicular axis theorem, the conditions that you need to follow or you need to fulfill are following. The first condition, let's say you have this irregular body over here. Okay, let's say it's a rigid body. If I said that this axis is x-axis and this axis is y-axis, okay? So this axis is passing through the center, okay? And perpendicularly it is passing. That is the point. So there are a few conditions that x-axis and y-axis should lie in the plane of body. Okay? The two axes must lie in the plane of body. The second condition, z-axis should be perpendicular to the plane of body. Okay?
Yes, ma'am.
The third thing, x and y are supposed to be perpendicular to each other. Okay? This is applicable only for 2D bodies or laminar bodies. Okay? Only for two-dimensional bodies or laminar bodies. And if you fulfill these 3 conditions, then you can write that inertia of z-axis is equals to sum of the inertia of these 2 axes. Okay, this is the statement. This is the final statement. That moment of inertia of z-axis is equals to sum of x-axis plus y-axis. Is that fine?
Yes, ma'am.
Yes, ma'am.
Lamina, basically, it is 2D body, 2D structure, like a sheet of a copy. A sheet of page is a lamina basically. ठीक है? Laminar structure, laminar flow. So basically sheets वाला चीज हो गया 2D body. Yeah. So this is the condition. You would remember it?
Yes, ma'am.
Yes, ma'am.
Let's come to the second theorem, and that is parallel access theorem. Okay. In this theorem, we get like this. Let's say this is a body. Okay. Let's say this is the center of mass of this body, and our axis is passing like this. Okay. So the inertia about this axis, I would say inertia about center of mass. Okay. And there would be obviously another axis which is like this. Okay. Inertia. The distance in between these two axes is a. So the statement goes like this, that I is equals to inertia about center of mass plus m, yani ki mass of the body, multiplied by a square. Now for this statement we have few conditions. First, a is supposed to be the perpendicular distance in between two axes. Okay, it is supposed to be the perpendicular distance in between two axes. The second thing, which we cannot compromise on, out of these two axes, one axis is supposed to be passed through center of mass for sure, right? It is a necessary condition that out of the given two axes, one axis is supposed to pass through center of mass. One axis must pass through center of mass. Two axes should be parallel to each other. Okay? Is that fine?
Yes, ma'am.
Okay.
Yes, ma'am.
So these are three conditions, and there is one privilege for you, that unlike this perpendicular axis theorem, you can apply parallel axis theorem for any body, right? For any body, whether it's 2D or 3D, right? कोई भी body हो, you can apply parallel axis theorem, unlike perpendicular axis theorem, which is applicable only for 2D bodies. You cannot use perpendicular axis theorem for a 3D body. Is that fine?
Yes, ma'am.
Yes, ma'am.
ठीक है, तो let's okay, so I really want you to remember a few points, that for perpendicular axis theorem, it is IG, IZ is equals to IX plus IY. ठीक है? And for parallel axis theorem, it is I is equals to I of C of M plus MA square. Okay, let's come to this question. It says three identical spherical shells, each of mass m and radius r. Each of mass m and radius r are placed as shown in this figure. Consider an axis x prime. देखो भाई आपको जो axis dotted बना रखी है, it is x prime. ठीक है? Which
Yes,
is
ma'am.
touching to two shells, and passing through the diameter of the third shell. Moment of inertia of the system consisting of these three shells about x prime axis. बढ़िया क्वेश्चन है, सॉल्व कीजिएगा. अभी टाइम हो रहा है हमारे पास 18:32. आप लोग मुझे 18:35 तक बता दीजिएगा. ठीक है, 3 मिनट दिए सॉल्व करने के लिए. अच्छे से दिमाग लगा के कोशिश करके अच्छे से सॉल्व करना. Okay, that's cool, Harshita. Actually, it's correct. Very good, Namrata. Yes, Misbah.
Ma'am, option B, 4mr square.
Very nice. Very nice. Now I'm feeling good. Otherwise, मेरे को ऐसा लगता है कि पता नहीं you're getting it or not because you're, you don't respond that much. That's nice. It's cool. Let's look at this diagram. Here you can observe that x prime is passing through the center of mass, this ring 1. But when it comes for ring 2, ring 3, it is not passing through center of mass, but it is passing through an axis which is parallel to the their center of mass wala axis. If this is their center of mass, x is passing through center of mass, then you can say na ki ma'am x prime is parallel to it. Yes or no? Yes.
Yes, ma'am.
So okay, let me change the color. So for ring number 1, for ring number 1, the inertia would be 2 by 3 mr square, right? As per the data that we have. But when it comes to ring 2 or ring 3, for both ring 2 and ring 3, the inertia can be calculated as inertia of center of mass plus m perpendicular distance, which is r here. So it is mr square, right? Bhai, perpendicular distance is this now, this distance, which is radius of this spherical shell, right? So
Yes,
just multiplied it by 2 since you have two rings here. Again, the inertia about center of mass is going to be 2 by 3 mr square. Add mr square into it, multiplied entire expression by 2. You will get 2 by 3 plus 5 by 3, and it would be 10 by 3 mr square, right? If I want to find out the inertia of this entire system, then it would be I1 plus I, right? It would become 2 by 3 mr square plus 10 by 3 mr square. Since denominator is same, I'm going to add them algebraically, right? Simply, it would become 4 mr square, which is your option B. Is it okay?
Yes,
yes,
ma'am.
ma'am.
Okay.
Okay, ma'am.
Gayatri, okay. Gayatri, have you got the answer? Because you're
Yes,
very,
ma'am.
huh?
Yes, ma'am.
Okay. So, bacha, respond, okay? I wait for everyone's response. Jennifer, even Jennifer didn't respond. Please, Om, kindly respond. Yes, thank you, guys. What is the name of this child? S. Kumar? Because then I would call you by your name now. Okay, just let me know. Let's do this question. It says the moment of inertia of an uniform circular disk of radius r and m about an axis passing from the edge of the disk and the normal to the disk is. बताइए, एक डायग्राम आपके लिए बना दिया है. आपको बताना है कि इनर्शिया क्या होगा अबाउट ए प्राइम, राइट? सॉल्व कीजिएगा. It is 1838 right now. Kindly answer me about 1840. Okay, Satyendra. Okay.
Ma'am, it's 3 by 2 mr square.
Very good, Mispa. Very nice. Let's solve this question. I need to find out the inertia about A prime, right? Now, can you see
Yes,
that
ma'am.
this A prime, okay, let me change the color here. This A prime is actually perpendicular, parallel to this axis, which is passing through center of mass. I would say that this is IC1, and the distance in between it would be R, as given in the question. So let's solve it. You would say कि ma'am I prime would be I of center of mass plus mr square. What is the inertia of center of mass about a disk? Half.
Half mr square.
Have mr square.
And when you add it, the inertia about A prime would become 3 by 2 mr square.
Right.
Very nice. Let's come to this question, and it will be the last question of today's lecture. It says, let's ignore it. A rod of weight W is supported by two parallel knife edges. Knife edges is this kind of a structure, right? On which you placed a rod or anything. It is used in labs actually. So knife edges A and B is in equilibrium in a horizontal position. The knives are at a distance D from each other. Okay? The distance in between these two knife edges is small d. The center of mass of the rod is at distance x from A. Okay, this is A knife edge, this is B knife edge, and the distance distance of the center of mass from A is x. Okay? The normal reaction at A. You need to find out the normal reaction at A. And you have four options. First is this. Okay? Second is this. Third is this. And fourth is this. Is it okay?
Yes, ma'am.
Cool. So it is 6:43 right now. Kindly give me answer about 6:45. Let me mark it here. 18:43 is the time that we have right now, and you will answer me around 18:45. Okay, Harshita, let me explain you this question by diagram. I said, okay, I don't know. Okay, Lokesh sir is calling. Okay, I will ask him what is the thing. Okay, here we have this rod. Okay, beta. And then I have two knife edges. Knife edges basically you can consider that we place this rod on the basis of these two triangles. Let's consider it like this. Okay, these are two supporters on which I place this rod. The position of this first is A and this is B. They said the distance in between these two edges is D distance. Okay, this is the center of mass of this rod. And this says the distance in between this knife edge A and this center of mass is X. So find out the normal reaction. I said normal reaction is a contact force. Whenever you put two objects into a contact, then they will apply the normal reactions, right? So normal reaction on A would be like this. Normal reaction at B would be like this. You need to find out normal reaction at A. You have 4 options above there. Is that okay, Harshita? Okay.
Ma'am, option 4 is.
Okay. So, Kiran, can you explain me why you arrived at this option? Misbah,
Yes, ma'am.
can you explain your solution?
Okay, ma'am.
Yeah?
Ma'am, n1x is equal to n2 in bracket d minus x, and n1 plus n2 is equal to w. Hence, n1x is equal to in bracket w minus n1.
Why you use W in the expression, Misbah? Namrata, can you unmute yourself?
Ma'am, wait.
Nee. Explain me the question. That's the point. Okay, let me solve it for you. See, from the center of mass, we will draw a weight force now due to Earth, which is mg. I told you about the torque. You have to understand ki, how the force is trying to rotate the body, where its torque is applying. If it is anti-clockwise, consider it as positive. If it is clockwise, consider it negative. This is the notion of torque in the physics. So basically, I would say ki, torque about point P is 0. Remember that rotational equilibrium wala thing? So torque about point P is 0. Now you will find the force and distance of the remaining forces now. So for example, for normal reaction about A, the distance is D, and normal reaction about W, the distance is D minus X, and it is 0. So from here you can calculate normal reaction as W times of D minus X divided by D. See, if you are giving me the answers, it's completely, commendable. Completely, I appreciate that thing. But please explain your answers. Otherwise, it looks like you are, scanning these questions. You are searching it on a Google, or you're doing some kind of cheating. If you cannot explain your answers, then it is difficult to digest it. Like you solved it by yourself. So please, whenever you answer the questions to me, please be prepared for this ki I will ask you ki how do you arrive at this point, how do you arrive at this question. Okay? I love those childs who said to me ki ma'am, I'm not getting it, I find it difficult, please explain it, rather than a kid who cheated in my class. I don't like that kid. Okay? So please, if you are solving it, it is much appreciated. Just give me the explanation. Even it's wrong na, I would appreciate you. Okay? I'm not that person ki you were wrong, oh let's put him in some another. Nah, I don't do that. If you are doing it correctly, if you are explaining it, then it's very well, very good. But if you are not explaining it correctly, even you give me the correct answer, then I'm not going to accept that answer. Are you getting my point? So please make sure that you do it. Thank you so much for being so nice. It really means a lot. Have a nice time ahead. Okay, we'll see you in the next class. And please prepare Newton's laws of motion for your upcoming test. Cool?
मैम एक गूगल फॉर्मेट चैट सेक्शन है, बच्चों को बोल दीजिएगा, फिल कर देंगे बच्चे.